This is a really exciting time because now you finally get to learn the shortcuts for taking derivatives. From when we started until now, we've been doing f of x plus h minus f of x all over h and finding the limit at h approaches 0 and doing all that algebra and simplifying, and you finally get a function. So today is the start of many derivative rules that you will need to memorize. Some are definitely easier than others. So today we've got the most basic ones we're going to learn. All right, so the first one here is called rule for a constant function. So when we have a constant, and it says if the function f is a constant, such as y equals 4 or any number where it's a horizontal line, and think about it, what is the slope of a horizontal line? Well, the slope of a horizontal line is just 0. So this is saying if f of x equals c, where c is a constant, then this notation is saying if you take the derivative of that constant with respect to x, then that derivative is 0. Another way of looking at it right here, let's say my equation was y equals 4. If I took the derivative of 4 with respect to x, my answer would be 0. The tangent line would have a 0 slope. I could also write y prime equals 0. If I said f of x equals 4, the notation would be f prime of x equals 0. Or I could say dy dx equals 0. All of this notation is saying the exact same thing. It's all saying that the derivative of the function is 0. So that's for constants. If this one is for positive integer powers of x. That means if you have an exponent here that's positive on x. Now this little rule is saying if you're going to take the derivative of x to some power where your power is positive, you're going to put the power in the front and basically multiply it times it now becomes a coefficient on x. And then your new exponent is 1 less. So for example, if my function is y equals x cubed, the derivative function, I'm going to move this 3 to the front, and it's now my coefficient. I have x, and now my new exponent is a 2. And again, all of this notation means the exact same thing. This one seems to be confusing people the most, but this one's more of an action. This is saying if I take the derivative of x cubed in terms of x, my answer is 3x squared. All right, so that's just if you have an x raised to a power. All right, this says constant multiple of a function. This is basically the same as the previous one, but this time if you have a number in the front. Now this is going to confuse you. It says c times u and this du dx stuff. And I don't really want to talk about that right now. That sounds kind of confusing. So I'm just going to give you a simpler example. So for a constant multiple, that's if you have a number in the front. So let's see how this one's different than this one here. So here, what you're going to do, you take your exponent and you're going to multiply it times the front. So it's 3 times negative 2. So that's now negative 6. And then I'm going to change the x to x squared. And that's it. Okay? So this is the 3 times the negative 2 becomes negative 6. And now I have a square. So the only difference between the previous problem and this one is if you have a constant in the front, you're going to take this number and multiply it times your leading coefficient there. That's all on that one. The next one says sums and differences. So again, this notation is saying if you have, let's say, a polynomial with multiple terms or any kind of function that has multiple terms that are divided or separated, by pluses and minuses, you just are going to take the derivative of each individual term. And so this is saying if you have the derivative of u plus or minus v plus or minus w, then you're going to take the derivative of the u function, the derivative of the v function, and then the derivative of the w function. So this notation looks really confusing, but this is really all it is. So here I have a function with multiple terms. I have 3 terms, one separated with a minus, one separated with a plus. All we're going to do is the same rules. We're just going to take the derivative of 2/3 x squared. So 2 times 2/3 is 4/3. I rewrite the x, and now my x has the new exponent of 1. 4 times negative 5 halves is negative 20 halves, and negative 20 halves reduces to negative 10. Oh, that should say, I see an error. That should be a cube right there. And then right here, this says 3x, so that should then become a 3. And that's it. That's just like polynomial terms. All right, so let's just do these 3 examples. Here's your original function, y equals x cubed plus 2x plus 5, and the directions say find dy dx. That means find the derivative. So I'm going to write using the notation I have here. Dy dx then equals the 3 is going to now be in the front, stays in x, and then the 3 here becomes a 2. The derivative here, this is really a 1, right? So 1 times 2 is 2, and this would become x to the 0, and x to the 0 is a 1. So the x actually just disappears. And then the derivative of a constant is 0. So this is your answer. Next, here's our function, f of x equals negative 6x to the 5th minus 2/3 x squared minus x plus 3. So f prime of x is 5 times a negative 6 is negative 30 x to the 4th. That one's done. Now 2 times a negative 2/3 is negative 4/3. Now becomes x to the 1st, so I'll just leave an x. Now again, I'll write it in there. So 1 times negative 1 is negative 1. And this now becomes x to the 0, which I don't write. It just goes away. And then the derivative of a constant is 0. So that one's done. All right, for this one, this one's a little bit more in depth. It says find all the points. So we're looking for ordered pairs. Find all the points on this function, g of x equals 2x to the 4th minus 9x squared minus 6, where the tangent lines are horizontal. So in this case, we still need to know what the derivative function is, but what we're looking for is, well, for what values of x is your derivative function then going to be equal to 0? So tangent lines are horizontal. That means we're looking to find when is g prime of x equal to 0, because this would be a 0 slope equals horizontal tangent. All right, okay. So first off, we're going to find the derivative. We need to find g prime of x. So that's 8x cubed minus 18x, and then the 6 just goes away, makes a 0. All right, so here I can factor here. So let's see, I want to set it equal to 0, and I want to factor. I can take out a 2, and I can take out an x. So I'm left with 4x squared minus 9. This binomial factors more. So I have 2x and 2x plus 3, 2x minus 3. So I actually get 3 values of x values. So let's see. I have x could be a 0. X could be negative 3/2. And x could be positive 3/2. Now, here's the thing. This question is asking, find the points on the original function where you would have horizontal tangents. So these x values are x values on the original function. So what you could do to find your y values, because it is asking for points, so that means we need to have an input and an output. We could type this in our calculator, and we could use our table, plug in the fractions. The 0 is the easy one. That one's just 0, negative 6. But to plug in, if I plug in negative 3/2, I plugged it in and I got negative 16.125. And then when I plugged in positive 3/2 into the original function here, not the derivative function, and then I got positive, nope, it was negative also, negative